Hello, guys. Greetings to you all. I've really missed you people. Frankly speaking, this is not a joke. This is not to say that I'm pretending or something of that sort. I've really missed you guys, and I just remember how we went through applied electricity with ease. Those who followed me, right? So applied electricity, I believe those who followed me will discovered the course to be one of the easiest because the way people were sending me message thanking me shows that yeah, they really understood the applied electricity. So with that thought, I felt like let me also pick one key courses, right, in the second semester courses. Okay, and the two key courses that I'm going to talk about, right, in all my tutorials will be the calculus and also the applied electronics, right. Applied electronics is one of the excited courses you can ever get on campus, right? The reason why I'm saying that is so excited is because it's full of reading. There's only some few calculations. But you see, in order to make it more fun, I'll be adding some simulations. Yes, I'll be adding some software simulations where you get to understand it better. So whilst you are reading your handouts, after watching my video, you just quickly go and read your handouts. I've already sent you some books, right? That will really help you in calculus and applied electronics. So once I give you the tutorials or once I upload my video, you just watch it. Watch how the simulations look like for the applied electronics. And once you get the understanding, you read your handout and you are good to go. So I'm not expecting anyone to get less than 90%. Anyone who follows me follows me, watch all my videos and subscribes to my channel. If you don't subscribe to my channel, please, you're not going to get your 90. Try as much as possible to subscribe to my channel, right? And share the video to others too. So once you subscribe to my channel, you're going to get 90%. Are you okay? It's magic. Follow me, make sure that you watch all my videos and share to others too. And I also thank Chris Paul, right? I can see that he has made a lot of people join the Telegram page. Yes, I really thank him very well, right? Please, he's an agenda man. You all know that, yes. And he's a very disciplined man too. Aside the agenda, yes. So if he's going for any position, I'll encourage you to vote for him. He's really disciplined man. Yeah, I've known him right from year one, and he was the class rep of the minerals department, like his class, and he really did a good job. I remember I was his TA at that time. So please try as much as possible to vote for him if you see him going for any position. But that was just by the way. Let's focus on what is very important. That is that is the tutorials, right? So like I said, we'll be talking about calculus and we'll also talk about applied electronics. But for today, our lesson is going to be based on calculus. Are you okay? So what are you going to learn under calculus? What exactly are you going to learn? I believe you are wondering on that. What exactly are you going to learn under calculus? Yes. Calculus, I will group it under three main sessions. Right. I'll group it under three main sessions. And what are the sessions? I'll talk about the limits. The limits, right? Then I'll talk about differentiation. Yes. I'll talk about differentiation. Then I'll talk about integration. But under this, we have different subsections, right? For instance, we are going to learn something new under the limits. I believe that you're only going to hear it from this video, right? Yes. I learned this when I was in senior high school. And when I was learning calculus here, I didn't come across it. But it really helped me when I was solving my limit questions. And that is the L'Hopital rule, right? It's more like spelling hospital, right? The L'Hopital rule. So I'm going to teach you the L'Hopital rule so that when you are struggling finding the limit of a function, you can apply the L'Hopital rule. With the differentiation, right, there are a lot. We have the first derivative, First derivative. We are going to talk about that one. Then we will also talk about the chain rule. Chain rule, right? We'll talk about the product rule. Right? We have different ones. You get it? But as time goes on, I'll be remembering them. I don't have all of them in mind. Right? I'll be remembering them and I'll be hitting on all of them. I'll talk about them one after the other. That is in all my videos. Today, my target is to make sure that I complete limit with you people, so that I'll not visit limit again. So the next time I come, we'll be talking about differentiation. By differentiation, we'll be having several videos, right? Then we'll talk about integration too. And what I really remember from this session is the integration by parts. The integration by parts. But we have different types of integration. Are you okay? I'm going to talk about all of them, right? By the close of the calculus tutorials, I'm going to talk about all of them. So in this case, even before you come to school, right, we'll still be having the calculus tutorials. But once you start class, I believe that all of you, if not all of you, majority of you will start with limits. So by the time you come to school, right, you should understand limit very well, so that when you get to class and the lecturer is teaching limits, you see it as something so cheap. Please, I'm pleading with you that if you understand limit from this section and you go to class, don't act as if you already know. Are you okay? I will really advise you. This is more like to help you follow the lecturer when the lecturer is teaching. That's the reason why I make the video. Sometimes when you are going to class for the first time and you are hearing it for the first time, it looks like a cinema to you. But once you are going to class and you have a fair knowledge under limits, anytime the lecturer is teaching, you can follow very well. The lecturer is also going to add maybe something new to it, and it will help you understand the concept. So please, don't use my video as just like the only thing you learn to write an exam. Okay? But I'm rather helping you get the concept. That's the reason why I try as much as possible to do it before you go to class. So today like this, I'll try to cover all the sessions under limits, so that when you come to school and the lecturer is talking about limits, you get the concept very well. So as you are talking about limits, I'll be under differentiation. So you'll be watching my video, and when you get to class, you feel like, yeah, I really understand differentiation. Do you get it? Then, whilst you are working on differentiation, I'll be making videos on integration. So you see that, yeah, I'm really flowing. I want to make your prep so easy. So, to set the ball rolling, let's talk about limits. I've already gotten a better definition for limits. When we say limits, let's go through it. Let me pick a different color. Okay. So when we say limits, what do you understand by limits? Said a limit can be defined as a value that a function approaches. So it's a value, right? That is, it can be y. Let me say the y part of the value is with the graph we have x and y. Okay. So it's a value, and that value is a y value, like I said. That's a function f of x, right, approaches as the input x. Okay, so these are all mathematical terms. Okay, so a limit can be defined as a value, which is the y value. That's a function, let's call the function f of s, approaches as the input is always the s value, as an input of that function, as an input of s, get closer and closer to some specific number. Are you okay? Let me use a graph to represent it. Let's assume that I have this graph. Do you get it? And on this graph, let's say that I have a continuous function. Please, the mathematicians move deep into limits. Do you get it? The mathematicians, they really move deep into limits. So there are certain times that they will say that, oh, this function has no limits. This function has no limit, like it cannot be defined. So that one is more like the discontinuous function. You get it? It's more like discontinuous function. But I'm rather going to talk about continuous function. So let's assume that I have a continuous function this way. Are you okay? I've just sketched a function. So we have, let's say, y values. This is the y part and this is the x part of the graph. Are you okay? And I have, let's say, 2, 3, 4. And I have -2, -3, -4, right? And this side, let me call it 1, 2, 3, 4. Then I have 5, sorry, -1, -2, -3, -4, -5, right? And -6. So maybe they can say that I should find the limit when x approaches, let's say, 4. Do you get it? So when x approaches 4, let me even take, how do you call it? When x approaches 4, okay, let's use 4. That is, it will be at this point. Okay. So at that point, our target is to find what's the value of y. Okay, when x approaches 4. This is not like the ones that, let's say, in mathematics, you see that they ask you to find f of 3, f of 4, f of 5. Okay, that one was learned when you're in senior high school. You get it? But this time, when they say find the limit when x approaches 4, we have 2 sections. You are going to test for the limit when x approaches 4 at the left hand side. That is when I'm moving from the left hand side, right? And I also check for the limit when x is approaching 4 from the right hand side. Okay, so let's say if I'm moving from the left hand side, which is more like this way, if the value of x is approaching 4, right? If I'm approaching 4, then what's going to be the value of what? Of x? What's going to be the value of y? So I'll assume that when I'm approaching 4, then the value of y is going to be somewhere what? Let's take 2.5. Okay. And if I'm approaching from the right hand side too, if I'm approaching the value of 4, right? What will be the value of y? That's the same thing. Okay. So since when I'm approaching from the left hand side, right, I'm going to get a value of 2.5. And when I'm approaching from the right hand side too, I'm going to get a value of what? 2.5. Then I'll say that the limit of this function is 2.5. Okay. There are certain times, let's say if I have a discontinuous function, right, it will not have a limit. When do we say that a function is not having a limit? Right. When I'm approaching from the left hand side, the value I get is different from the value I get when I'm approaching from the right hand side. If the values are different, then I would say that the function has no limit. But if the values are the same, then we can say that the function has a limit. You get it? But a function which is not having a limit is not another discussion over here. We are talking about functions that has limits. Okay, so generally mathematically, right, if let's say I want to find a limit of a function, we express it as the limit as s approaches a specific value, which is a, right? F of x is equal to what? A specific value which can be termed as, let's say, L. So if I want to find a limit as s approaches, let's say, a specific value for a particular function f of s, then it will be equal to what? L. So this is the general representation of what? Of a limit. So this is exactly what you are going to see in most of our videos, right? Limits, although, is very interesting, but it has a whole lot, right? You need to solve more questions. I'll send you a link which has thousands of questions under limits. I'm not going to say that like that's what's coming in the exam. I don't know what's coming in your exams. Actually, I'm in the electrical department and I don't know what the mathematics lecturers will be setting for the exams under calculus. But if you keep on solving them, there's different techniques of solving it. I'm going to give you all the rules. If you keep on solving them, you get to understand it better. Okay. And any question that drops under limits, you'll be able to solve it and solve it well. Okay. So let me, before I even set on to the limit rules, before I introduce the limit rules, right, let's solve a typical question. Okay. So they can say that find the limits as s approaches what 5, and the function is x squared plus 2x minus 4. This is, I think, one of the easiest. All you need to do is to substitute the value of what? Of x. That is when x is approaching 5. Substitute the value of 5 wherever you find x to get your answer. So to solve this one, I will say that it's going to be what? 5 squared plus what? Plus 2 multiplied by 5 minus 4. And this is going to give us 25 plus what? 10 minus 4. So what will be the final answer? We're going to get the 35 minus 4, which is 31, right? So that's going to be the final answer. So you just substitute the value of 5 to wherever you find the x. Okay. But don't think, this is very simple, right? It's the simplest you can ever get. But there are complicated ones. And you need what? You need rules in order to what? To get the answer. Okay, let's take a typical example. They can also ask you to find the limit as s approaches what? Approaches 3. We have x cubed minus 27 all on what? On x minus 3. So this is a typical question. Let's see what's happening here. See, if I look at this value, let me just substitute 3 into it. Let me substitute 3 and see what happens. So I have, let's say, the denominator. If I substitute 3, it's going to be what? 0. Okay, once it becomes 0, then it's undefined. It's not logic. Okay, so there are certain times you need to what? Break down the function. Okay, so you need all your mathematical knowledge. I believe you did partial fraction when you were in senior high school. Yes, it's one of the easiest courses in senior high school. So here like this, you need to break it down. Some of them you need partial fraction. Some of them too you need binomial expansion. Okay. So for instance, if I look at the value up there, the function up there, right? I have s cubed minus 27, which is the same as what? S cubed minus 3 cubed. I believe you agree. Yeah. So 3 cubed is the same as what? 27. Okay. So in this case, if you can recall very well, there was some expansion which says that a cubed minus b cubed equal to what? A minus b, or into brackets, a squared plus ab plus what? Plus b squared. If you can recall. Yes. So in that case, this function, or let's say if I have s cubed minus 3 cubed, is the same as what? X minus what? Minus 3 into bracket what? X cubed plus 3x, right? Plus what? Plus 3 squared. Something like this. So in that case, see, the numerator has been what? Has been broken down to this form. So the limit there can be written as limit as s approaches what? 3. We have x minus 3 x cubed, s squared, okay. So s squared plus 3x plus what? 3 squared, right? All divided by what? All divided by x minus 3, okay. So now the x minus 3 can cancel the x minus 3 here. Now that they've been able to cancel, we can see that we are having limit as what? S approaches what? 3 x squared plus 3x plus what? 3 squared. You see, we've been able to eradicate the points where the denominator is 0. You shouldn't substitute when you get the denominator to be 0. Okay, it's not always right. So once you do that, you are going to get your answer wrong. So when the denominator is 0, you need to make sure that you simplify the function to eradicate the 0 denominator before you substitute. So at this point, I can now substitute to say that it's 3 squared plus 3 into bracket 3 plus plus another 3 squared. So at the end, I'm going to get 9 times 9 plus 9 plus 9. And 9 3 is 27. Do you get it? Okay, yes, sure. I believe you get it. If you don't understand, you can revisit the video again and you understand it better. So that is the binomial expansion. Yes, there are some of them you need binomial expansion. Some of them you need to apply the partial fraction. The partial fraction. Please, if you've forgotten your partial fraction, try as much as possible to revise. Under calculus, right? The prerequisites, some of the topics under mathematics that you need is what? Is logarithm, the log, trigonometry. You also need partial fraction, right? Partial fraction, Then, I think these 3 is the things that you need to know when you enter the calculus class. If you are struggling with these things, there are certain steps that the lecturer will show which will make you so confused. So these 3 topics, at least please understand them very well. Algebra is something that is common. If you are in the university and you are struggling with algebra, then I'm pleading with you, try as much as possible to revise your algebra very well. Because as a science student, I'm not expecting you to struggle with algebra at all. No. A science student shouldn't struggle with an algebra. But sometimes the logarithm is quite confusing, the trig is quite confusing, and the partial fraction, that one too is quite easy. But the trig and the log, you need to memorize some formulas and some rules. So I'll advise you to also to understand your trig and your logarithm very well before you come to school, right? So that you find the calculus so easy. These are the things that really disturb the students when they come to the school. So please try to revise your trig, log, partial fraction, and let's say algebra before you come here. Okay. So I've solved some small limit questions with you, but we have limit rules. We have limit rules that will guide you when you are solving limit questions. And we are going to talk about all the rules, right? Let me talk about the rule 1. Rule 1. You get it. You need to apply them. So please, I will advise you to how do you call it? At this point, if you are just watching it, right? I will always advise you to have a pen and a paper when you're watching my videos. But if you are just watching it without making notes, at this point I'll beg you that go and pick a pen and a paper so that you write the rules. Let the rules be part of you, so that anytime you get a limit question, you'll be able to apply the rule. What's the first rule? I'm going to go through them quickly and you understand it. Trust me, you really understand it. So what's the first rule? If I have limit as s approaches a value which is a under two functions, let's say two sum of functions, let's say I have g of x plus f of x, are you okay? Then I can say that is equal to what, or equals to limit as s approaches a constant a, f of x plus what, the limit as s approaches the same constant g of x. So I can apply expansion. Are you okay? So it's the same as finding the limit as s approaches a f of x plus the limit as s approaches a g of s. So that's the first rule. Please take note of it. It also holds for subtraction. So rule 2 says that if I have limit as s approaches what, a, f of x, let's say minus g of x, then what will it be? I believe you already know. So let me just write it. It's going to be limit as s approaches what, a, f of x minus limit as s approaches what, a, g of x. The only difference is the minus sign and the plus sign. Are you okay? So the rule 1, rule 2 is very easy. What about the rule 3? Let's talk about rule 3. Rule 3. Please, you should understand all the rules, else you are going to struggle. Right? So if I have a limit, right, as s approaches a, you get it? Then I have a constant being multiplied with a function. What will it be? I can bring the constant out and I'll find the limit as s approaches a, f of what? Of x. Do you get it? A typical example is, let me give you a typical example. Let's assume that I have limit as s approaches what? 3. And I have 2x squared plus 4x plus, let's say, 8. Okay, this expression, right, can be also written as limit as s approaches, let's say, 3. I can factorize 2 out. 2 into bracket x squared plus what? 2x plus 4. Okay. And with this one, I can say that it's the same as 2 multiplied by what? Limit as s approaches 3, x squared plus 2x plus 4. I believe you get the concept. So that is the third rule. If I have a constant being multiplied with a function, right, I can bring the constant out and find the limit of the function. Then after getting the results, I'll multiply the constant with the results of the limit calculation. Are you okay? So let's move on to the fourth rule. We have 11 rules in all, and I want to end my video in an hour. I don't want my video to exceed an hour. So let's try to make sure that we cover all and solve some questions. So rule number 4, right? What is rule number 4 saying? Rule number 4 is stating that if I have a limit as s approaches what? A, right? Then I have a product of two functions, that is f of x multiplied by g of x, right? Then I can find the limit as x approaches a, right, f of x. Then I'll multiply it with the limit as s approaches a, G of x. This one too is very, very simple. Okay. So it holds for addition, it holds for subtraction, and it holds for what? Multiplication. Someone will talk about division. What is division? How is division to apply there? That leads us to what? Rule number what? Rule number 5. If I have limits as s approaches what? A, right? Then we have f of x on what? On g of x. Please take notes. This is very, very important. Okay. So I can also find the limit as s approaches a, f of x, all divided by what? The limit as s approaches a, g of x. So once I find the value, I can just divide and get my answer. Do you get it? Yes. So let's talk about rule number 6. Rule number 6. Please, I'm going through all the rules with you. I think I have 11 rules. So once I expose you to all the 11 rules, try as much as possible to make sure that you understand them. Let's be part of you. That's the reason I'm asking you to pick a pen and a paper so that you understand it very well. So if I have limits as s approaches what? A, right? F of x or exponent n. How can I solve this? Right? I can bring the limit inside f of x and all of them will be an exponent of n. This way, I can find the limits as s approaches a, f of x, right? Then all exponents n. So once I get the value of the limit as s approaches a, f of x, then I now apply the power. Okay, that is rule number 6. What about rule number 7? Rule number 7. Rule number 7 states that if I have limit of a constant, just a constant, okay. So limit of a constant is the same as the constant. Nothing changes. So limit of a constant is the constant. So we don't have anywhere to substitute x. So if I have a constant, a typical example is find the limit as s approaches 3 of 4. The answer is 4. Are you okay? Yes. So let's move on to the next one. That is the rule number 8. Yes. Rule number 8. What is rule number 8 stating? Rule number 8 is stating that if I have limit of x, limit as s approaches, let's say a, of just x, right? Then I will just substitute and I'll get a. Okay. So it doesn't mean that you are just going to get x. Like what we solve when we are starting the limits, when we are solving the question. You see, we solve something, we are just substituting the value of what? Of x in the function. So for instance, if I have limit as s approaches, let's say 3, 2x, then it means I'm going to get what? What am I going to get? I'm going to get 2 multiplied by what? 3, and that will give me 6. Okay. So what about rule number 9? We are moving gradually. So rule number 9 states that if I have limit as s approaches, let's say a, x exponent n, then I'm going to get what? A exponent n. That is very simple. Okay. So it's more like rule number 8, rule number 9. They are almost the same. Okay. So what about rule number 10? Rule number 10. So rule number 10 makes it clear that if I have limits as s approaches, let's say a specific value a, right? Then I have n roots of x. Then the answer is going to be what? The n root of what? Of a. I just substitute a. But what if it's a function? That leads us to rule number what? 11. And that is the last rule. If I have limits as s approaches, let's say, a constant, and I have n root of a function, this time it's not x, but it's a function, right? then I can say that it's the same as what? Nth root of limit. I can bring the limit inside as x approaches a f of x. Please take note of the rules. If you are very good with all the 10 rules that I've stated here, then it means that your solving of limits will be easy for you. I think limit is one of the easiest, right? But sometimes you can get a stubborn question that you need to sit down and analyze it very well. When it comes, you might get something that is easy. But at times too, you can get something difficult. Are you okay? I'll solve some questions here before we talk about what? The L'Hopital rule, right? I'm going to solve some questions here. Let's say if I have a limit of infinity, right? I'm going to solve it over here, and we will move on to the L'Hopital rule very soon. Do you get it? So, sometimes they can ask you to find the A. Most of the times, right? The A can be either 0 or infinity. You should take notes. Sometimes the A can be any constant, let's say 2, 3, 4, 5, 6. But sometimes to the A can be 0 or infinity. 2 multiplied by 0 is what? 0, right? What about 2 multiplied by infinity? It's infinity. Take note of it. If I multiply a constant by 0, I'm going to get 0. If I multiply a constant by an infinity number, I'm going to get infinity. Do you get it? What about the division? If I have, that is multiplication. But what if it's dividing? If I divide a number with an infinity, right, then it means it approaches what? 0. I have 1 on 2. This is what? 0.5. Right? What about, let me even use 10. Multiples of 10. 1 on 10 is going to be what? 0.1. 1 on 100 is going to be what? 0.01. 1 on 1000 is going to be 0.001. So you can see that as it approaches a bigger number, right, the value is at 0. So as 1 approaches infinity, right, is 0. And the same way when we have 0 is undefined. It's not infinity, but it's undefined. Are you okay? Undefined. This is undefined. Do you get it? So it's undefined. Take note of it. Anytime you have 1 over, let's say, 0, it's undefined. Are you okay? So let's proceed. Let's proceed. So these are the things that you need to take note of. When you have a number over infinity, right, it's going to be 0. But if it is multiplying, it's going to be infinity. Take note of it. It's very, very important. Okay. So let's take a typical example. A question can come like, find limits as s approaches at 2. We've already solved some, so let me solve some with you. Find limit as s approaches 2. We have 8 minus 3x plus what? Plus 12x squared. So with this one, it's very easy to solve. You just substitute what? 2 to wherever you find x. So this one is going to be, let's say 8 minus what? 3 multiplied by 2 plus 12 into brackets 2 squared. At this point, you can use your calculator, but if you're not having a calculator, you can just use your brain. If only you can. Are you okay? But you'll be using the calculator, so I'll encourage you to use calculator. You are going to get 8 minus what? 6 plus 12 into bracket 4, right? So 8 minus 6 simply is 2 plus 48. This is going to give us 50. Are you okay? Yes. Let's take another example. We should find, I'm going to bring something that is quite complicated. So by simple, limit as s approaches what? -5. x squared minus 25 all on what? On x squared plus 2x minus 15. So your factorization should also be important. You see the top there is difference of 2 square. So if I have x squared minus 25, it's simply going to be what? This is the same as 5 square. Are you okay? That's the reason I'm saying difference of 2 square. 25 is my 5 square. It's going to be x plus 5 and x minus 5. Are you okay? And if I have x squared plus 2x minus 15, this is also factorization. So I need to look for two numbers that when I multiply, I'm going to get negative 15. When I multiply, I'm going to get negative 15. But when I add them, I'm going to get 2. And this is, what values are those? We have 5, negative 5, and what? And 3. When I add them, I'm going to get negative 2. So that is not right. So I'm going to choose 5 and negative 3. Okay. So let's substitute and see. I'm going to get x squared plus 5x minus 3x minus what? Minus 15. So I can factorize. Please, if you are struggling with this thing, you need to learn your factorization very well. So I can get x into brackets x plus 5, right? Minus 3 into brackets x plus 5. But then I'm going to get x minus 3 and x plus 5. So with this, I can find the limit as s approaches what? Negative 5. Then the top there is going to be x plus 5 and x minus 5. And down here, I'm going to get what? X minus 5 and x plus 5. This cancels this. Okay. So you see that after expanding, we're able to cancel something out. And now we have, this is 3, sorry, not 5. So we have limits as s approaches what? Minus 5, x minus 5, all on what? X minus 3. Now when I substitute negative 5 into x, I'm not going to get 0 at the denominator. So now we can substitute. So I'm going to get minus 5 minus 5, all on what? Minus 5 minus what? 3. And this gives minus 10 on what? On minus 8. So I can simplify. So 2 goes here, 4, and 2 goes here, 5. So that is going to be the final answer. You see how simple it is? Very, very, very simple. Please don't complain. If you are struggling to watch a video, so repeat the video once again. Okay. And please subscribe to the channel. Okay, let's continue. So if it's infinity, what do we do? Let's say I should find the limit as x approaches what? Infinity. Okay. Find the limit as s approaches infinity. X cubed plus 2x divided by what? 5x squared. 5x cubed minus x squared plus 4. There's one way of solving it. I'll also talk about the L'Hopital rule. But before solving this one, before talking about the L'Hopital rule, right? That is very, very important. Before talking about the L'Hopital rule, I'm going to solve this one in another way. Okay. So when you get something like this, right? You look for the term, right? The term with the highest degree, or the value of x in the expression with the highest degree. So with this one, we can see that the value of x over here, the highest degree is what? Is 3. We are going to divide each term with the x with the highest degree. Okay, so this is how you are going to solve it. You are going to find limit as s approaches what? Infinity. S cubed divided by what? The highest degree was s cubed. So you are going to divide this term by s cubed. Plus, you are going to divide all the terms by s cubed. all divided by what? 5x cubed all divided by s cubed, right? Minus s squared all divided by what? S cubed plus 4 all divided by what? S cubed. Someone will ask, what is a term, right? A terms are what? That's the reason why I want you to learn algebra. So terms are just separated by additions and subtractions. So if I have an algebraic expression and I have additions and subtractions, so the terms are separated. As soon as I pass by addition, I meet another term. So you see, this one we have the numerator has 2 terms, right? And the denominator has 3 terms. So I'm going to divide each term by the highest degree of what? Of the x, right? So I'll look for the s with the highest degree and I'll divide each term with that. So now with this one, I'm going to get what? Limit as s approaches infinity. Let's solve this. Okay. Sorry, I want to break it down a little. So I'm going to get limit as s approaches infinity. When I cancel this, what am I going to get? I'm going to get 1 for the first term, right? Plus it will be left with 2s what? X squared. Because this x can cancel this, so that it will be left with s squared. Okay. All divided by, at this point, this s cube cancels this s cube. So I'm going to get 5 minus what? 1 on x. 1 on x, right? Plus 4 on x cube. So now we can substitute the infinity. So we have 1 plus 2 over infinity square is the same as infinity. Let me make it. Infinity square is the same as infinity. Okay. All divided by 5 minus 1 on what? Infinity plus 4 on infinity cube. Infinity cube is the same as infinity. And I told you that if I have an infinity value, it approaches what? 0. So all those terms can be what? Can be 0. Right? So I now have 1 plus 0 all on what? 5 minus 0 plus 0. And this is going to give me 1 on 5. Then I get the final answer. Okay, so that's how we solve it when I have limit of infinity. But sometimes, take note, sometimes after doing all these things, you still get infinity on infinity. There's a way of solving it, and that is when I'll introduce the L'Hopital rule. Okay, if I get infinity over infinity, I need the L'Hopital rule. Or if I get 0 on 0, we call them the, how do you call it? We call it the indeterminate, right? If let's say I have a limit and after substituting, I get an indeterminate value. That is, let me spell the indeterminate so that you understand what I'm saying. Right? I have indeterminate value. Right? So, let me spell it again. So I have indeterminate value. Okay. This is an indeterminate value. So how do you know that it's an indeterminate value? After substituting everything, I get either 0 as numerator and 0 as denominator, and infinity over infinity. Okay. So there's a way of solving it, and we will talk about the L'Hopital rule that will help you in solving questions like that. Okay. Before I talk about the L'Hopital rule, right? Let me talk about a last question. Let's say if I have a function, let me take a question. For instance, I'm asked to find the limit as h approaches what? 0. 6 plus h all squared minus 36 on what? On h. So you see, this one, when I substitute 0, it's going to make the denominator 0. And that is haram. Okay. So I need to simplify the expression before I do what? I substitute the value of h. So how do you do that? I have 6 plus h squared. I can expand it, which is going to give me, you see, there's a short way. As a science student, we know that if I have 6 plus h squared, it's the same as a plus b all squared. And this is the same as what? A squared plus 2ab plus what? Plus b squared. So in that case, I'm going to get the 6 squared is going to be what? 36 plus 2 times 6 is 12. So 12h, right? Plus h squared. So that is the expansion for this one. So at the end, I'm going to get limit as h approaches what? 0. I have 36 plus 12h plus what? H squared minus 36 all divided by what? H. So this one can cancel this 36 here because negative and positive are equal. So at the end, I'm going to get limit as h approaches what? 0. And I have 12h plus h squared all on what? On h. Now I can factorize h out, which I'm going to get limit as h approaches what? 0. We have h into bracket what? 12 plus h all on what? On h. This h cancels this h. So I'm going to get limit as h approaches 0, 12 plus h. Now I can substitute the what? The value of 0, the value of h, which is 0, to get 12 as my final answer. Are you okay? Yes, yeah, okay. So now let me talk about the L'Hopital rule. That's the last rule. Please take notes. Sometimes you get to a point where you are struggling, and once you apply the L'Hopital rule, you are good to go. But before I talk about the L'Hopital rule, I want to introduce you to some basic concept under differentiation, which you all know. If let's say I have 3x squared, right, and I'm asked to differentiate this, we know that the power or the degree comes to multiply with this, then we subtract 1 from the what? From the degree. So for instance, if I'm asked to differentiate something like this, it's going to be 2 times 3 x 2 minus 1. Okay. And this is going to be 6x. Do you get it? Yes. So that is one basic differentiation that you need in the L'Hopital rule. This is very, very simple. You've done it in calculus when you're in senior high school. So I'm not expecting anyone to struggle. But if you are struggling, you can move back the video and understand that concept very well before you learn the L'Hopital rule. Because if you are struggling with differentiation, this type of differentiation, the L'Hopital rule becomes difficult as well. Okay. So the general rule is if I have ax b, then it's simply going to be what? A times b x b minus 1. Okay. So what is the L'Hopital rule stating? If I have an indeterminate limit, right? For instance, let's say I have a certain limit as s approaches what? A, f of x, and what? And f of g of x. Sorry, let me make it g of x. You see, if I should simplify, let's say I'm applying the limit, and at the end I had something like 0 on 0, or I had infinity on infinity, then we term it as what? As indeterminate, like what I spelled. So it's indeterminate. With this one, the rule states that if I have such a limit, right, please take notes. This is one of the secrets that most of you will not even come across before going to write the exam. Are you okay? So if I have the limit like this, and after substituting, I get the 0 over 0, infinity over infinity, then the best is to what? Is to find the limit as s approaches what? A, the derivative of x over the derivative of what? Of g, right? Once I find the I'll keep on finding the derivative till I get perfect value. So you keep on finding the derivative till you get a perfect value. I'm going to solve one example, then you see. So it's the same as finding the limit as s approaches a, right? D on what? The x of f of x, all on what? D on the x of what? Of g of x. Let's try an example. Sorry. Let's try an example like the one we solved. You see, this one we had 1 out of 5. We can apply the L'Hopital rule here to get the same 1 out of 5. Let's see. So let's pick the same question again. Let's pick the same question. For instance, if I'm asked to find the limit as s approaches what? Infinity, right? X cubed plus 2x all on what? On 5x cubed minus x squared plus 4, right? Assume I'm asked to find this one. Let's assume, see, if I should substitute infinity at all the values of x, let's see what I'll get. So if I should find infinity of s, it's going to be what? S cubed plus 2 into bracket what? Infinity, all divided by what? 5 infinity cube minus infinity squared plus 4. So this, the numerator is going to be infinity and the denominator will also be what? Infinity. We are going to get infinity values. So the rule says that we can find the derivative of it. So we can say that limit as s approaches what? Infinity. If I find the derivative of s cubed, I'm going to get what? 3x squared plus what? Derivative of 2s is going to be what? 2. All divided by, if I find the derivative of 5s cubed, I'm going to get 15x squared minus what? 2x, that's the derivative of this, plus 0. So I've cleared it. So this derivative of a constant is 0. Why? Because if I have a constant, it's the same as 4x exponent 0. Are you okay? So it's going to be 0 times 4 x 0 minus 1. 4 times 0 is 0. So everything becomes 0. Are you okay? So you see, there's still s. If I should substitute infinity again, I'm going to get infinity over infinity. So I can still find the derivative. So you keep on finding the derivative till you get a sensible value. Are you okay? So derivative of 3s squared, how do I get? I'm going to get 6x plus 0. 2 is 0. All divided by what? 30. I'm going to get 30x minus 2. Do you get it? 30x minus 2. So now, you see, if I should still substitute, I'm going to get infinity. So I'm going to find limit again as s approaches infinity. I'm going to find the derivative again. So 6x will give me what? 6. All divided by what? 30. Because minus 2 is 0. Okay. So now we have a constant here and we cannot substitute the infinity again. So it's going to be 6 on 30. 6 goes here. 5 goes here how many? 6 goes here 1. 6 goes here 5. Which is the same as 1 over 5. As we had in our previous one. Okay. We had 1 over 5 there. Okay. So we can also use the L'Hopital rule in solving this one. Let me take another question under the L'Hopital rule. For instance, if I'm asked to find the limit as x approaches 2, right? X squared minus 4 all on what? On, how do you call it? X minus 2, right? With question like this, if I substitute 2 there, let's assume I substitute 2, or let's assume I'm solving it. Let me solve it here. I'm going to find limit as s approaches what? 2 x squared minus 4. That's the division rule. Limit as s approaches what? Approaches 2 x minus 2. So if I substitute, I'm going to get what? 0 on 0 if you should do it well, this is going to be 4. 4 minus 4 is 0. 2 minus 2 is 0. So you see, it's indeterminate. Since it's indeterminate, I can apply the L'Hopital rule. I'm going to find limit as s approaches what? 2. And this is going to give me what? 2x minus 0. All divided by what? All divided by 1. Okay. So now, I'm going to get limit as s approaches what? Approaches 2. And that gives me what? 2x. And this I can substitute, which is what? 2. And this will give me 4. Okay. Someone can choose to use expansion. So you see, with derivative, there are 2 ways of doing it. Someone can choose to use expansion. I can find limit as s approaches what? 2. Difference of 2 square up there. I'm going to get x plus 2 and what? X minus 2. All divided by what? X minus 2. This cancels this one. We have limit as s approaches what? 2, x plus 2. And that will give me 2 plus 2. And this is 4. Okay. So you can choose to use the L'Hopital rule, or you can choose to use the expansion. So it's better to know all of them, so that when you get a question and you are struggling, right, you quickly use the one that you understand. Not the one that you understand, the easiest one, okay, to solve it. So it's better to learn all of them, so that you will not struggle at the exams hall. Sometimes expansion becomes so difficult, but you will see that if I apply the L'Hopital rule, I'll get it as easy as possible. So please take note of it. I think we are done. I don't want to be spending more time, right, on my videos. But before we conclude, let me solve one tough question. Okay, one tough question under limits. Please bear with me. I know that it's past the 1 hour, but let me solve one tough question and get the concepts, so that you'll be able to solve more. So let's assume that I have limit as s approaches what? Infinity to lane what? Lane 5x plus 1 minus lane 3x squared plus x plus 1. This is one of the tough questions that you can get. Okay, so let's see how we solve it. So I have limit as s approaches what? Infinity. Do you get it? Do you remember your trig rule? They said if I have log 2 minus log 3, what is it going to be? It's going to be what? What is it going to be? It's going to be log into bracket what? 2 on 3. Please don't forget this, the trig rule. And also, if I have 2 log 5, it's going to be what? Log 5 square. Okay, so you are going to apply the log rules here. So the first one, we can say that we have lane what? 5x plus 1 squared minus lane what? 3x squared plus x plus 1, right? This one to brackets. Now we've been able to apply this rule. Now we can apply this rule. We are going to have limit as s approaches what? Infinity. We are going to get lane into brackets 5x plus 1 all what? All squared on what? On 3x squared plus x plus 1. Do you get it? Yes. Are you okay? Yes, we are okay. So with this one, let me even clean out the brackets over here. Right, let me clean this one here. That is limit of infinity. Right, it's the same as limit as x approaches what? Infinity, lane of this. I can bring the limit inside. So I can say that lane into brackets limit as s approaches what? Infinity. Let me expand the top there. If I should expand it, I'm going to get 25 x squared plus 10x. Yes, 10x plus 1. Please, if you've forgotten, go and learn. The expansion. It's basically applied by a plus b, a squared, b squared, or let me say a plus b squared is the same as what? A squared plus b squared minus 2ab or plus 2ab, since it's plus. Okay, or we can say a squared plus 2ab plus b squared. Science students should not struggle with this. Okay, so we've done the expansion, all divided by what? 3x squared plus x plus 1. Now you see, we have infinity, right? So we can apply the L'Hopital rule, because expanding this again can cause headache. So let me just apply the L'Hopital rule and move on. So I have learned limits as s approaches what? Infinity. If I should insert infinity, then I'm going to get infinity at the top and I'll get infinity down too. So I just want to apply the L'Hopital rule. So with this, I'm going to get 50x, that's the derivative of 25x squared, right, plus 10, and this is going to be 0, all divided by what? 6x, right, plus 1. Very good. So we differentiate this, we differentiate this, we differentiate this will be 0. So we don't write that one. Then it's going to be ln into brackets limit as s approaches infinity. I can still differentiate because I'm going to get infinity over infinity. So I'm going to get 50 on what? On 6, because this is going to be 0, 0. Okay. So this is the same as ln into bracket what? 50 on 6. I can simplify this. 2 goes here 3, 2 goes here 25. So at the end, what do I get? It's going to be ln 25 on 3. Then you use your calculator. Once you use your calculator, you get your final answer. Are you okay? So that's all for the day. If you are struggling with anything, right, I didn't want to pass over an hour. I've already passed the time, so please, if you are struggling with anything, just go back, right? Please join the Telegram page. I'm going to put the link in the description, right? Over there, this is very serious. Most of you watch the video, you don't join the Telegram page. If you join the Telegram page, you'll be getting questions. For now, right, around 12 noon tomorrow, please, I'll put this video there. But after 12 noon, right, I'm going to put a link there which will expose you to numerous questions under limits. You need to solve more questions. So I'm going to put a link there which will expose you to numerous questions under limits. So once you join the Telegram page, you will get access to that link. And once you get access to that link, it will help you. I've already also shared some books. Some of you joined later. I'm going to share the books again. Please join so that you get access to those books and you solve more questions. Because practice make man perfect, not watching the video. Watching the video will not make you perfect. You understand. You say, yeah, you understand. But if after watching the video, you put it aside, you will not get it. So you practice make man perfect. Try as much as possible to do it, to practice it. Are you okay? I want to move fast because it looks like I'm spending more time. But please, before I say bye-bye, subscribe to my channel. Are you okay? I'm begging you. And also, let me also thank Kwesimpo again. Kwesimpo, I'm really grateful, right, for letting more people join the Telegram page. That place is where we have a lot of conversation. If you have any question that you want us to talk about, there are geniuses there. All of you are genius, right? Once you drop it in, you get someone to solve. If you don't get anyone to solve and I come on board, I'll try as much as possible to solve it. If you all cannot solve it, then we'll put it aside. Or we will seek solution from other sources. Are you okay? So please, join the Telegram page and subscribe to my channel. Don't just download, but subscribe to it. Are you okay? In the Apply Electricity video, I had over 1,000 people, even not over 2,000 people watching all my videos, but it's only like 200 who subscribed. Okay, so please subscribe to my channel, and that's a way of paying me back. Okay, that's the only way you can pay me back. When you watch and you appreciate, you just subscribe to the channel, and it's more like paying me back. Okay, I wish you the best of luck. I'll be happy to see you on campus. When you see me on campus, just wave. I'll wave at you back. I love you all the best. Bye bye.